हेलो एंड वेलकम टू flameinstitute.com। टुडेज टॉपिक है जो हमारा फिजिक्स का, दैट इज इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटर्स। सो इक्विपोटेंशियल, इलेक्ट्रिक पोटेंशियल और पोटेंशियल एनर्जी। The electric lines of a force always leaves an equipotential surface। कहते फर्स्ट क्वेश्चन क्या है कि इलेक्ट्रिक लाइंस ऑफ अ फोर्स ऑलवेज लीव एन इक्विपोटेंशियल सर्फेस। कब? एट एन एंगल टू द सर्फेस, पैरेलल टू द सर्फेस, परपेंडिकुलर टू द सर्फेस और नॉन। द राइट ऑप्शन इज, सॉल्यूशन देख लेते हैं सबसे पहले। सॉल्यूशन में क्या है जी, हमारे पास गिवन है कि इक्विपोटेंशियल सरफेस इज ऑलवेज परपेंडिकुलर टू द सरफेस। जब भी इक्विपोटेंशियल सरफेस की बात करते हैं वो हमेशा ही हमारा जो है सरफेस के साथ परपेंडिकुलर में होता है, तो दैट मीन्स हमारा थर्ड ऑप्शन इज द राइट ऑप्शन, परपेंडिकुलर टू द सरफेस। A unit charge is taken from one point to another over an equipotential surface. Then work is done on the charge. Work is done by the charge. Work on the charge is constant. या no work is done. ठीक है जी। अब हमें क्या पता है कि जब पोटेंशियल डिफरेंस अलोंग इक्विपोटेंशियल सरफेस इज जीरो, सो वर्क डन इज जीरो। सो दैट मीन्स हमारे पे क्या आंसर क्या आ जाएगा हमारा, नो वर्क इज डन। नेक्स्ट क्वेश्चन इज, इनसाइड अ होलो स्फेरिकल कंडक्टर द पोटेंशियल क्या होगा, कांस्टेंट होगा, varies directly as the distance from the center, varies inversely as the distance of center, varies inversely as the square of the distance from the center. Now what is the answer for that? Inside the hollow spherical conductor the dielectric field is zero, hence potential is constant. So first option is the right option. Choose the correct statement. The statements are, an electron at a higher potential has a lower potential energy, an electron at a lower potential has a lower potential energy, electron moves from higher to lower potential, या none of the above. The solution क्या है इसका हम देखते हैं कि the potential energy of a charged particle is an external field of QB. Electron at higher potential has higher potential energy and at lower potential energy. Electron moves in a direction opposite to the field that is lower to the higher potential. So answer आ जाएगा हमारा second, an electron at a lower potential has lower potential energy. Choose the correct statement. A zero potential point is always a zero electric intensity point. A zero electric intensity point is always a zero potential point. At a point of zero electric intensity, electric potential may not be zero or all of the above. A zero potential point may not be zero field potential point. For example, if charge Q, negative, positive Q and negative are placed at the four corners of the square, E is not equal to 0 but B is equal to 0. So, a zero field point may not be zero potential point. For example, hollow charged conducting spherical shell. So, at a point of zero electric intensity, electric potential may not be zero. The right option is 3. The next question is, when the separation between two charges is increased, the electric potential energy of the charges increases, decreases, remains the same, may increases or decreases. What is the solution for that? We know that U is equal to K Q1 Q2 upon R1 minus R2 square. So, if separation increases, U may decreases or R increases depending upon the nature of the charges. So, the answer is may increases or decreases. The next question is, choose the wrong statement. Which one is the wrong statement from them? An equipotential surface is normal to electric field lines. Potential increases in the direction of the electric field. We may have zero potential but non-zero electric field at a point in space. Potential is a scalar quantity. The solution is potential decreases in the direction of electric field. So, potential increases in the direction of electric field is the right option. That is second. V inversely proportional to 1 upon R. That's why potential increase होता है electric field की direction में. Out of the following two statements, as we move in the direction of the field, potential goes on decreasing. If a charged body is moved within the field, work must be done by field. A is correct, B is wrong. A is wrong, B is correct. Both are correct or both are wrong. Hanji. What is the solution for that? When a charged body is placed in an external electric field, a force acts due to the field. Hence, work is done by the field. So, both A and B are correct. Potential at the point of a pointed conductor is maximum, same as at any other point, zero or minimum. Solution कंसेप्चुअल है इसका सोल्यूशन दैट सेम एज एट एनी अदर पॉइंट पोटेंशियल होता है जो एट एनी पॉइंट एट द पॉइंट ऑफ अ पॉइंटेड कंडक्टर इज सेम एज एट एनी अदर पॉइंट. Out of the following two statements, three charge system cannot have zero potential energy. The mutual potential energy of a system of charges is only due to positive charges. A is wrong, B is correct. A is correct, B is wrong. Both are correct or both are wrong. Which one the answer is? Any system of charges can have potential energy and any system can have zero potential energy. So, both A and B are wrong. If two conducting spheres are separately charged and then brought into contact, the total energy of the spheres is conserved. Total charge on the sphere is conserved. Both total energy and charge is conserved. Or final potential is always the mean of the original potential of the two spheres. Solution is, when two conducting charged spheres are bound in contact, charge is only conserved as the sphere are charged separately, there may be change of energy. So the right option is second, that is the total charge on the spheres is conserved. Electric potential at some point in space is zero, that then at that point electric intensity is necessarily zero. Electric intensity is necessarily non-zero. Electric intensity may or may not be zero, or electric intensity is necessarily infinite. When potential at a point is zero, field may or may not be zero. कहते जब भी potential जो है वो point पे zero होता है तो field कभी कभी zero होती है, कभी कभी नहीं होती. So third option is the right option. Electric intensity may or may not be zero. At each corner of an equilateral triangle, identical charges are placed. Then, at the center of the triangle, the resultant electric intensity is zero. At the center of the triangle, the net electric potential is zero. System is the energy of the system is zero. Resultant on the intensity, electric intensity at any corner is zero. So, for identical charges at the corners of an equilateral triangle, the resultant field is zero but not the potential. So, first option is the right option. On the perpendicular bisector of an electric dipole, the electric intensity E and potential B are both zeros, both not equal to zeros. E equal to 0, B is not equal to 0. E is 0, B not equal to 0. The solution is, on the perpendicular bisector, potential is 0 because the charges are equal and the opposite, but field is not 0. So, E is not equal to 0 but B is equal to 0. Third option is the right option. When an electron approaches a proton, their electrostatic potential energy decreases, increases, remain unchanged, all of the above. What is the solution for that? Proton, electron are opposite charges which attract each other and potential energy decreases. So, first option is the right option. The mutual electric potential energy of any two negative charged particles are U1 and U2 when their distances are of separation are D1 and D2 respectively. If D2 is greater than D1, then U1 is greater than U2, U1 is less than U2, U1 is equal to U2 cannot be decided. U is inversely proportional to the distance D. So, U1 is greater than U2. If an earth plate is brought near positively charged plate, the potential and capacity of the charged plate increases or decreases, increase, decrease, increase. Capacity increases because more charges accumulate the positive plate, and the potential decreases because the positive opposite field against the field between the plate decreases. So, potential is decreases and the capacity is increases. At the point In space, the electric field points towards north. In the region surrounding this point, of the rate of the change of potential will be zero along which direction? North south or east west? As the field is directed towards north, equipotential surface is east-west. So rate of charge of potential is zero in that direction. That is the fourth option, east or west. Two charged spheres of radii 10 cm and 15 cm are connected by a thin wire. No current will flow if they have same charge, same potential, same field on their surface, same energy. The right option is no charge or no current flow if the points are at same potential. So that is PD between the potential difference between the points is 0. So second option is the right option. They are the same potential. An electron and proton move through a potential difference of 200 volts. Then electron gains more energy, proton gains more energy, both gain same energy, none of gain energy. W is equal to Ke gained EV. So both electron and proton will gain same energy. Third option is the correct option. The next question is an electron of mass m and charge E is accelerated from rest through a potential difference V in vacuum. Its final speed will be 1/2 mv square is equal to EV. So if we have to find the V, that is equal to 2 EV upon m. So first option is the right option. For four identical charges, each of charge Q are placed at the corners of a square. Then at the center of the square, the resultant electric intensity E and the net electric potential V are. E is not equal to 0, V is equal to 0, E is equal to 0, V not equal to 0, E and B both are 0, E and B both are not equal to 0. Let's have a square and there is the charges Q on the A, B, C and D. So all the identical charges, सारे charges जो है वो identical है. So B is not equal to 0. Due to the symmetry, EC is equal to 0. That means the second option is the right option. That said E equal to 0, B not equal to 0. Electric potential on the surface of a hollow conducting sphere is V. The electric potential is V upon 2 at a distance R by 2 inside the sphere, R square by 2 from the surface of the sphere and outside it, 2R from the center of the sphere, 2R from the surface of the sphere and outside it. So the right option is 2R from the center of the sphere. Solution देख लेते हैं जी इसका. We have V surface is equal to Q upon R. So V dash is equal to V upon 2. That means KQ upon R, KQ upon 2R. So R is equal to 2R. So that's why key 3 is the right option. Next question is the charge Q is the at the center of the semicircle of a diameter AB. If work done is moving a charge Q along the semicircle is W1 and work done in moving the same charge Q along the path ACB is W2, then W1 is greater than W2, W1 is less than W2, both are equal to 0, both are not equal to 0. Let's have this semicircle. We have this semicircle of diameter AB. Now we have the triangle ABC. Solution is electric field is a conservative field. The hence work done is independent of the path. A and B are equipotential surface. So W1 equal to W2 equal to 0. Both are 0. So key 3 is the right option. A charge Q is placed at an corner A of a square ABCD. Its center is 0. A test charge Q is moved along 3 paths, namely BC, BCD and BUD, doing the works W1, W2, W3 respectively. Then they 3 are the zeros. The W1 is greater than W2 is greater than W3. W1 is equal to not equal to 0 but 2 and 3 equal to 0. W1 is less than W2 is less than W3. What is the answer? We have this square and the circle. About that, the square is ABCD and the charges is Q, and the there are the works W1, W2 and W3. So let's get the solution. We have WBB is greater than VC. So VA is equal to VC. That means third option is the right option. That means W1 equal not equal to 0 but W2 and W3 equal to 0. The next is in hydrogen atom, electron of charge -e and mass m revolves around the nucleus in a circular orbit of radius r. The electrostatic potential energy of an electron is. These are the options. Now, second is the right option. Why? Electrostatic potential energy of an electron is equal to the potential of nuclear field at distance r into charge of the electron. So that's why option 2 is the right option. Now, E upon 4 pi epsilon naught into minus E. Minus E is minus E square upon R. So, key 2 is the right option. Next one is the electric field of a point charge Q. A certain charge is carried from point A to B, C, D and E. Then the work done is Q is at the center of the circle. Least along the path AB, along the path AD, 0 along any one of the paths and least along AE. The solution is electrostatic field is conservative, so 0 along any path. Two conducting spheres of radii R1 and R2 are at the same potential. Their charges are in the ratio R2 upon R1. Both have the square R1 upon R2, R1 upon R2 ka square. So the solution is, we know that V1 is equal to V2. So Q1 upon 4 pi epsilon naught R1 is equal to Q2 upon 4 pi epsilon naught R2. So Q1 upon Q2 is equal to R1 upon R2. So third option is the right option. A condenser is charged to a potential B by connecting it to a battery. If the charge on the condenser is Q, then the energy stored in the condenser is 1 by half QB. Work done by the battery during charging is half. Work done by the battery during charging is QB, or both 1 and 3 are true. So let's get the solution. The solution is, we have the battery when a capacitor is charged by connecting to a battery of potential B, the work done by battery is equal to QB, and energy stored in the capacitor is half QB. So both 1 and 3 are true. Identify the correct order in which the gain in kinetic energies increases in the following cases. Alpha particle accelerate through PD, potential difference of 2B. Proton accelerated through the potential difference of 2B. Neutron accelerated through the potential difference of 3B. Or electron accelerated through the potential difference of 5B. So the option are there. First is the right option. That means first, second, first, third, वन एंड फोर्थ. पहले आएगा सेकंड, फिर आएगा थर्ड, फिर आएगा फर्स्ट और फिर आएगा फोर्थ. हाउ? Kinetic energy is equal to QE. So KED is equal to 4EB, KEP is equal to 2EB, KED is equal to 3EB, and KEO is equal to E is equal to 5EB. So key 1 is the right option. When a charged particle of a charge q and mass m is accelerated through the potential difference of v, then the velocity acquired by it is: b is directly proportional to q, b is directly proportional to m, v proportional to capital B, or v proportional to q, 1 upon 2. So now B is correct, both B and C are correct, both B and D are correct, or both A and C are correct. So right option is both B and D are correct. Let's get the solution. Half mb square is equal to qb, then v is equal to 2qb upon m under root, then v is inversely proportional to q half under root half and m minus half. So right option is right 3. The next question is, when an identical drops each of potential B coalesce to form a bigger drop of potential B1, then B1 is directly proportional to N1, B1 is equal to N2 upon 3, B1 is directly proportional to B2 by 3, B1 is directly proportional to V. And which one the correct? A and C are correct, A and D are correct, B and C are correct, or B and D are correct. So the right option is, solution है हमारे पास है 4/3 pi r 3/1 that is equal to n pi 4/3 pi r cube, and r1 is equal to n 1/3 r. So V1 is equal to 1 by 4 pi epsilon naught NQ upon N 1 by 3 R. Then answer is N 2 by 3 V. So V and D are correct. So fourth option is the right option. two cons two concentric spheres of radii r and capital R and r small r, they have the similar charges with the equal surface densities rho, then electric potential V at their common center is which option? हाँ जी, the solution is we have this question जिसमें हमारे पास दो सेंटर्स है, अलग अलग दो आर है, दो रेडियस है, एक स्मॉल आर है, एक कैपिटल आर है, और इसमें जो हमारा जो पोटेंशियल है दैट इज V, सो V इज इक्वल टू V1 नॉट इक्वल टू V2. Now K root A1 upon R, A2 upon capital R plus, so K रो इसमें से कॉमन आ जाएगा, अंदर आएगा 4 पाई R स्क्वायर प्लस 4 पाई R स्क्वायर अपॉन स्मॉलर R कैपिटल R. दोनों को जब एलसीएम लेंगे तो ये आ जाएगा K माइनस 4 पाई R प्लस R. So rho upon epsilon naught R plus R is the option. So key 1 is the right option here. Next question is match list 1 with list 2. List 1 is electric potential inside a charged conducting sphere, electric potential outside conducting charged sphere, electric field inside the non-conducting charged sphere, or inversely proportional to square of the distance, directly proportional to distance from the center, constant. And fourth one is this. What is the answer? The answer is A का G, B का H, C का F और D का E. The solution है electric field inside the conducting sphere is zero potential constant. Electric field potential conducting sphere V out equal to K rho Q upon R. Electric field inside non-conducting sphere E inside is equal to K Q upon R cube R. Electric field outside conducting sphere is E out is equal to KQ upon R cube. So key 4 is the right option. Match the list. We have the two lists. And these are the options. So second option is the right option. How? Let's get the solution for that. When two like charges are brought nearer, potential energy increases. When unlike charges are brought near, potential energy decreases. Mutual forces are not attracted. Due to dielectric medium, force between charges decreases. So key 2 is the right option. Next is match list 1 and 2. Here is electric potential due to point charge V, electric field intensity, electric potential V, electrostatic potential. That is equal to this one. So the right option is we have V is equal to theta upon 4 pi epsilon naught R and E is equal to minus dV upon dx. V is equal to E dot R. EPF is equal EPE is equal to FD is equal to QED. So first option is the right option. Electric energy is stored in the capacitor. Capacity of capacitor when dielectric between the plates with disconnecting them. The battery. Potential difference between the plates of capacitor when electric medium is inserted between the plates with disconnecting the battery. Here are some options for there. What is the option? Option C3 is the right option. Let's have the solution. Electric energy is stored in the capacitor. In the electric field between the plates. Capacity of capacitor increases when the dielectric is introduced between the plates. Potential difference decreases and remains the same. So, key 3 is the right option. The next is statements given है दो. When a proton with certain energy moves from low potential to high potential, then its kinetic energy decreases. Statement 2 is the direction of electric field is opposite to the potential gradient. Which one is true? First is true, second is true, second is correct explanation of 1. 1 is true, statement 2 is true, but statement 2 is not the correct option of the 1. Statement 1 is true, 2 is false, 1 is false, 2 is true. So the right option is a statement or is it true? 1 is true, second is true, and statement 2 is the correct explanation of statement 1. When proton moves from lower potential to higher potential, that is in a direction opposite to the field of the declarated. So d is equal to minus dv upon dx. So key 1 is the right option. The next question is when proton and alpha particle which are identical initial at rest are accelerated by the same electric field for the same time interval, de Broglie wavelength of a alpha particle is less than that of the proton. Statement 2, it is given electric field to get particle momentum of the time or at the time of acceleration is inversely proportional to the charge. Which question is correct? The statement 1 is true, 2 is true, but 2 is not the correct explanation of statement 1. ये दोनों अलग अलग है एक से. T is the same, proton V is equal to AT is equal to QE upon MT, QE upon M equal to T, so MB is equal to QET. So D particles V is equal to 2Q ET upon 4M, and after cutting that is equal to MB is equal to QE upon 2T. So now we just so de Broglie wavelength of a proton and alpha particle are not same. Hence key 2 is the right option. Next is proton and deuteron are projected with the same velocity normal to the electric field of the same strength require different times of interval travel to acquire velocity of the same magnitude. Statement 2 is in the electric field in getting certain velocity from rest, the time of acceleration is inversely proportional to the specific charge of the particle. So which option is true here? So first option is true. The statement is true. 1 is true, 2 is true, and 2 is the correct explanation of statement 1. The next question is, statement है a circle is drawn with a point positive charge at a center and the work done is taking the unit charge once around it is zero. The displacement of unit positive charge is zero. The right option is statement 1 is true, statement 2 is true, but statement 2 is not the correct explanation of statement 1. For a point charge concentric circle of equipotential surface, this 2 displacement is not 0 but delta be equal to 0. So key 2 is the right option here. When two charged spheres are connected by conducting wire and the charge flows from smaller sphere to large sphere. Next is smaller sphere is at high potential when equal charges are imparted to both the spheres. So which statement is true? हाँ जी, statement 1 is true, statement 2 is also true, or statement 2 is the correct explanation for the statement 1. How? Let's get the solution for that. We have rho directly proportional to 1 upon r. That is smaller the radius, जितना smaller radius होगा उतना ही large charge density होगा. So charge flows from smaller to large. That's why key 4 is the right option. Statement 1. Electric potential at any point on a equatorial line of electric dipole is 0. Statement 2. Electric potential is a scalar. Then which answer is? Option is true. The option solution is V is due to electric dipole at any point. So second is a true, statement 1 is true, statement 2 is true, but statement 2 is not the correct explanation of statement 1. V is due to electric dipole at any point is equal to this. So now the next question is statement 1. In bringing an electron towards a proton, electrostatic potential energy of the system increases. Second statement is that potential due to proton is positive. Which option is true from this one? Statement 1 false, statement 2 is true. Statement 1 false है और statement 2 जो है वो true है. How? And on equatorial line, every point is equidistant from the both the poles. To electric potential is work per unit charge, so it is a scalar. So that's why key 4 is the right option. Statement 1. The surface of a conductor is an equipotential surface. Second statement is the conductor allows the flow of charge. Which option is true from them? If the surface of the conductor is not an equipotential surface, the field would not be radial to surface. Conductor has free electrons. So statement 1 is true, second is also true, and statement 2 is the correct explanation of statement 1. Statement 1. When charge is shared between two conductors, then there is no loss of charge, but there is loss of electrostatic energy. Statement 2. Law of conservation of energy false. Which statement is true? Let's have the solution. We have the solution that from conservation of a charge, when charge is shared between two conductors, total charge remains the same. As final charge is not same, there is charge in electrostatic potential energy and total energy remains the same. So that's why key 3 is the right option. The key 3 is statement 2 is correct and statement 1 is true and statement 2 is false. So key 3 is the right option here. Next question is condenser stores charge, energy, both or none. The solution is the condenser stores electrical energy. So electrical and energy. So that's why both are the correct options. First charge भी होता है उसमें और energy भी उसमें होती है. A condenser is charged by connecting to a battery and then the battery is disconnected. If a dielectric slab is introduced between the plates, then potential decreases, capacity decreases, potential increases, charge increases. Which one is the right option? Let's have the solution. Potential decreases. So first option is the right option here. Two conductors when connecting by a wire, charge flows if they have different charges, different potentials, different capacities or different charge densities. Now let's have the solution. Charges flows only when there is a potential difference. Charge तभी flow करता है जब वो वहाँ पे potential difference हो. So that's why second option is the right option. In a charged capacitor, the energy is stored in the field between the plates, the positive charge, the negative charge, none of the above. Let's have the solution. In a capacitor, energy is stored in the field between the plates. So, first option is the right option. The capacitance of a parallel plate condenser depends upon area of the plate, medium between the plates, distance between the plates or all of the above. Capacitance of a parallel plate capacitor C is equal to K A epsilon naught upon D. So all of the above are true. Next is the capacity of a spherical conductor is independent of its volume, surface area, material or none of the above. Capacity of a spherical capacitor does not depend upon the material. So third option is the right option. The capacity of a parallel plate condenser depends upon material of the plate, charge, potential, or none of the above. Capacity of a parallel plate capacitor C is equal to K A epsilon naught upon D. So none of the above is the right option.
स्टार्ट तो नहीं किया कर काफी सारे ना उसमें एक से ज्यादा बनेंगे जो ऑन ऑफ करने वाला काम होता है ना थोड़ा फास्ट किया दोनों हाथ यूज
वो
कर लो
इसके साथ थोड़ा सा हो जाता है।
दोनों हाथ यूज कर लो इस हाथ से ही इसको यहाँ पे रखो
ठीक है। हाँ जी. The next question is the capacity of a parallel plate condenser can be increased by decreasing the distance between the plates, increasing the area of the plates, introducing the dielectric slab between the plates, all of the above. The solution is for parallel plate capacitor, C is equal to K epsilon naught upon D. So all of the above is the right option. The condenser used in the tuning circuit of radio receiver is paper condenser, electrolytic condenser, Leyden jar or gang condenser. In tuning circuits, gang capacitor is used because capacity is variable. So the true option is gang condenser. The next question is the condenser having predetermined polarity is ceramic condenser, paper condenser, electrolytic condenser or mica condenser. The electrolytic capacitor have predetermined polarity, so third option is the right option. Electrolytic condenser is having aluminium oxide as dielectric medium, have very low capacity because of the plates are widely separated, can be used both in AC and DC circuits. All of the above are true. Aluminium oxide is used as a dielectric medium, so first option is the right option. A parallel plate conceptor is connected to a battery. The quantities charge, voltage, electric field and energy associated with the capacitor are given Q naught, V naught, E naught and U naught respectively. A dielectric slab is now introduced between the plates with the battery still is connection. The corresponding quantities now given by Q, V, E and U are related to the previous ones. So, what is the right option? Energy stored and charge increases. So, U is greater than U naught. Fourth option is the right option. When two charged condensers are connected in parallel, the electric energy of a system is conserved. The total charge of the system is conserved. Both charge and electrical energy is conserved. Neither charge nor electrical energy is conserved. Charge and electric energy is conserved. So, second option is the right option. The plates of the charged condenser are connected by the conducting wire. The quantity of heat produced in the wire is proportional to square of the capacity of conductor, inversely proportional to the square of the potential of the condenser, proportional to the length of the wire or independent of the resistance of the wire. The plates of condenser are connected by the conducting wire. The heat produced in the wire is independent of the resistance of wire. So, fourth option is the right option. Parallel plate condenser is connected to a battery and charged. Then the battery is disconnected and the distance of separation between the plates is increased with the help of insulated handles. Then capacity and charge decreases, potential and charge increases, energy and capacity decreases, Capacity decreases, charge remains the same. Capacity decreases because C is equal to E epsilon naught A upon D, but charge remains the same. So third option is the right option. A parallel plate condenser is charged by connecting it to a battery. The battery is disconnected and the glass slab is introduced between the plates. Then potential increase, electric intensity increase, energy decreases or capacity decreases. When dielectric slab is introduced without battery, capacity increases, UVE decreases. So energy decreases. Then right option is third. An aluminium foil is negligible thickness is inserted between the plates of the parallel plate condenser such that its length is parallel to the plate. If the foil is electrically insulated, the capacity of the condenser will be increased, decreases considerably, remains unchanged or become infinity. Aluminium is a conductor, though K is equal to, so decreases considerably. So second option is the right option. Next is the capacitor works in AC circuits, DC circuits, both the circuits or neither AC nor DC circuits. Capacitor works with AC and DC but it stops DC and allows AC. So both circuits are the right option. The next question is, two identical capacitors are joined in a parallel charge to a potential B, separated and then connected in series. That is, the positive plate of one is connected to the negative plate of the other. So what is the right option here? The charge on the plates connected together are destroyed. Charge on the free plates are enhanced. The energy stored in the system increases. The potential difference between the free plates is 2B. When connected in series, the potential become 2 times of each. So the potential difference between the free plates is 2B. The next question is, out of the following statements, the capacity of a conductor is affected due to the presence of an uncharged isolated conductor. A conductor can hold more charge at the same potential if it is surrounded by dielectric medium. Both are the correct. Both A, B are wrong. A is correct, B is wrong, A is wrong, B is correct. So both A and B are correct. How? Capacity of conductor affected due to the presence of uncharged isolated conductor because a capacitor is formed, and in presence of dielectric medium potential decreases, so conductor can hold more charges. Then key 1 is the right option. A parallel plate capacitor has plates of unequal area. The larger plate is connected to the positive terminal of the battery and the smaller plate of to its negative terminal. Let Q plus and Q negative be the charges appearing on the positive and negative plates respectively. So Q positive greater than Q negative, Q positive equal to Q negative, Q positive is less than Q negative, or information is not sufficient to decide the relation between Q plus and Q negative. The solution is, irrespective of the area, magnitude of the charge on both the plates is the same. So Q plus is equal to Q minus. Space between the plates of a parallel capacitor is filled with the dielectric slab. The capacitor is charged and then supply is disconnected to it. The slab is now taken out. Then work is not done to take out the slab. Energy stored in the capacitor reduces. Potential difference across the capacitor is increased. Potential difference across the capacitor increase. The right option is potential difference across the capacitor is increased. How? In presence of slab, the potential of the capacitor is Vc upon K. The dielectric slab is removed, potential increases. So, key 4 is the right option. A small uncharged metallic sphere is positioned exactly at a point midway between two equal and opposite point charges. If the sphere is slightly displaced toward the positive charge and released, then what will be the answer? All of the above, that it will move further towards the positive charge, its potential energy will decrease and kinetic energy will increase. Total energy remains constant but non-zero. So all of the above are correct. How? This is the plus and negative sphere इसमें पढ़ा है. तो being a metallic sphere, it is induced with negative charge. Potential energy increases, kinetic energy potential energy decreases, kinetic energy increases. Due to attraction, energy is conserved. So key 4 is the right option. The capacity of the parallel condenser is quadrupled if the charge on it is quadruple P. Potential difference is made 1/4 of the original value. The area of each plate is doubled. The distance of the separation is halved. All of the above. The true option is C is equal to Q upon B, then E epsilon naught A upon D. So all of the above is the true option. A parallel plate condenser is charged by connecting to a battery. Without disconnecting the battery, the space between the plate is completely filled with the medium of dielectric constant K. Then potential becomes 1 by K, charge becomes K, energy becomes 1 by K, electric intensity becomes K. Charge and energy increases, so charge becomes K times. In the diagram, A and B are two metal plates arranged as shown. A small particle having a mass m and negative charge q is held at the rest of potential A and constant potential difference is applied between A and B. Plate A is higher potential. Particle is then released. Its path as it falls will be best represented by the curve. कौन से कर्व से इसको रिप्रेजेंट हम करेंगे. पार्टिकल मूव्स इन अ पैराबोलिक पाथ टुवर्ड्स पॉजिटिव प्लेट. सो सेकंड ऑप्शन इज द राइट ऑप्शन. The next question is, two vertical metallic plates carrying equal and opposite charges are kept parallel to each other like a parallel plate capacitor. A small spherical metal ball is suspended by a long insulated thread such that it hangs freely in the center of the two metallic plates. The ball, which is uncharged, is taken slowly towards the positively charged plate and is made to touch that plate. Then the ball will stick to the positively charged plate, come back to its original position and will remain there, oscillate between two plates without touching them. When wall is brought towards positive plate, negative charge is induced, so it is attracted to by the positive plate. When touches the plate, it becomes positively charged and repelled, moves to the other sides of the oscillate. Therefore, key 3 is the right option. A condenser A of capacity 4 mF has charge 2 mc 20 mc, and the another condenser B capacity 10 has a charge of 40. If they are connected in parallel, then charge flows from B to A, charge flows from B to A till common potential is reached, charge flows from A to B till potential is reached, A to B till charge on them are equal. So the right option is charge flows from A to B till common potential is reached. How BA is equal to QA upon CA, that is equal to 20 upon 4, that is 5 MB, and 40 upon 10 is equal to 4 MB. So the VB is less than VA, charge flows from A to B. So third option is the right option. When a dielectric material is introduced between the plates of a parallel plate capacitor, the capacity becomes K times 1 by K square times K square times, or 1 by K times. The right option is C is equal to K C naught. C naught is equal to epsilon naught A upon D. So K times is the right option. If the electric intensity between the plates of a parallel plate condense is E and the electric energy stored per unit volume of the medium, then what is the answer here? Energy stored per unit volume, energy density E upon V is equal to 1 upon half E epsilon naught E square. So first option is the right option. Two condensers of a capacity C1 and C2 are connected in parallel and charged, then the ratio of charge on C1 to charge on C2 is C2 upon C1, C2 upon C1 का square, C1 upon C2, C1 upon C2 square. Then the solution is potential on both are equal. V1 is equal to B2. So Q1 upon C1 is equal to Q2 upon C2. That means C1 upon C2 is the right option. A parallel plate condenser of area A has charge Q, then the force of each plate is. Each plate is in the electric field of the other plate. F is equal to EQ, that is equal to Q square upon 2 epsilon naught A. So third option is the right option. You are given 3 identical capacitors. How many different combinations you can make using all capacitors each time? And capacitors can be arranged n plus 1 ways. So if they have the 3 capacitors, so 3 plus 1 is 4. So right option is the 4. A parallel plate condenser has charge Q, surface charge density S, capacity C, and distance of separation D between the plates. Then the electric intensity between the plate is. E is equal to epsilon naught upon density upon epsilon naught, so Q upon A epsilon naught, that is Q upon CD, because Q is equal to epsilon naught A upon D, so Q upon CD is the right option, that is the fourth option here. The next is two spherical conductors of radii R1 and R2. R2 is greater than R1 are placed concentrically in air. The two are connected by the copper wire. Then the equivalent capacity of the system is. It is a combination of the sphere on separate capacitors. So pi for second option is the right option. Three identical condensers are connected in different combinations using all three each time. Arrange the following cases in the increasing order of the effective capacity. All in series, all in parallel, two in series and one in parallel, two in parallel and one in series. What is the right option here? So first option is the right option. First all in series, then all are in the series, and 2 in series, then 2 in parallel. So key 1 is the right option. A capacitor of a capacity C1 is equal to 1 Faraday is charged to a potential of 100 volts. The charging battery is then removed and it is connected to another capacitor of capacity C2 that is equal to 2. The other plate of C2 is earthed, then the steady state. A charge on C1 is equal to 100, charge on C1 is 50, charge on C2 is 0, charge on C2 is 50. What is the right option? The right option is A and D. If as B is same, then Q1 upon C1 is equal to Q2 upon C2. So Q2 is equal to 100 upon 2. That means 50. So, and charge C1 is equal to 100, then key 2 is the right option. Statement 1 is the strength of the electric field in the charged and isolated capacitor is decreased. The electric slab is inserted. Statement 2 is when dielectric slab is inserted between the plates of a charged capacitor, electric field is generated due to the induced charge opposite to the external field. Which one is true? Statement 1 and 2 and both are the truths, and statement 2 is the correct explanation of statement 1. How? When dielectric slab is introduced between the plates, electric field strength decreases due to induced charge in the dielectric. So, key 1 is the right option. When a condenser, statement 1, when a condenser is charged by a cell, then the energy stored in the condenser is half of the work done by the cell. Statement 2, condenser is charged at gradually increasing potential but cell gives charge at constant potential. Which statement is true? Statement 1 and 2 both are true, and 2 is the correct explanation of statement 1. Work done by the cell is equal to QB and energy stored in the capacitor is half QB. So, key 1 is the right option. Statement 1, on charging the capacitor, energy is stored in it. Statement 2, in charging the capacitor, work is done by the battery. Which answer is true here? We have statement 1 is true, statement 2 is true, but statement 2 is not the correct explanation of statement 1. On charging capacitor, electric field is established between the plates. So, energy is stored in the field. Work is done by the cell to move charges. So, second option is the right option. Statement 1. When dielectric is placed between the plates of a capacitor with disconnecting the battery, energy stored in the capacitor decreases. Statement 2. Due to dielectric slab, capacity increases. Which option is true here? Option 2. Statement 1 is true. Statement 2 is also true. But statement 2 is not the correct option explanation of statement 1. Because when the battery is removed and the dielectric is introduced, then Q on the plate does not change but V decreases. Capacity increases. So, key 2 is the right option. Statement 1 is two capacitors are connected in series to a battery. If a dielectric medium is inserted between the plates of one of the capacitors, the energy stored in the system will increases. Statement 2, on inserting the dielectric medium, the capacity of a capacitor increases. Which one is true? The statement 1 is true, statement 2 is true, and statement 2 is the correct explanation of statement 1. When dielectric slab is inserted across one of the capacitor, the energy stored increases, capacity also increases. So that's why key 1 is the right option. Statement 1. Two capacitors are connected in parallel to a battery. If a dielectric medium is inserted between the plates of one of the capacitor, then the energy stored in the system will increase. Statement 2. On inserting dielectric medium between the plates of a capacitor, its capacity increases. Which option is true here? The first option is true. Statement 1 is true. Statement 2 is also true. And statement 2 is the correct explanation of statement 1. How? The capacitor connected to parallel potential remains same on inserting dielectric slab, but capacity increases. So, energy stored capacity increases. Key 1 is the right option. Statement 1. When a charged capacitor is discharged through a resistor, heat is produced in the resistor. Statement 2. In charging a capacitor, energy is stored in the capacitor. Which statement is true? Statement 1 भी true है, statement 2 भी true है, but statement 2 is not the correct explanation of statement 1. How? When capacitor is charged through the wire, heat is produced on charging, electric field is established and energy is stored. So, key 2 is the correct option. Thank you.